Welcome to In Between the Tech, brought to you by Mauser Electronics. Today, we explore the expansive world of additive manufacturing. What started with plastics and polymers has increased in scope to include diverse materials like metals, ceramics, biomaterials, and beyond. Stefanie Brickwede, Managing Director at Mobility Goes Additive, joins us to share her insights on the advantages and applications within this technology. Could you tell us about Mobility Goes Additive and the work being done there?
Yeah, so Mobility Goes Additive is a network, an association for additive manufacturing or 3D printing that was founded 10 years ago with 9 founding members. And meanwhile, we are approximately 150 companies, institutions throughout the whole supply chain of additive manufacturing. I'm also responsible for additive manufacturing at the German railway company Deutsche Bahn. And there we started our activities 10 years ago. And when we started that, we wanted to get in touch with other companies to learn about their experiences concerning technologies, materials, and use cases. And we were looking for an existing network and didn't find an appropriate one. So we founded our own one. And that was the start of MGA, Mobility, and also meanwhile, Medical Goes Additive. And the overall task and topic we want to have is we want to encourage other companies to start with additive manufacturing and print parts for their products, for the machines, for whatever use case you can think of. And yeah, we want to lower the hurdles which still exist in that brilliant technology and to do this jointly. And what we do in the network is we are always coming from the user's perspective. We are not an R&D network, although that is also done, but usually we try to focus on the user's needs. And of course, we have a lot of industry players in the network for machines, printing services, materials, software solutions, also R&D institutes, as well as universities. So to cover the whole supply chain, to help users to push the boundaries and to print more parts in different technologies. And 2 or 3 years later, after we founded the network, our member companies addressed us and said, what you're doing in the network, this is also urgently needed in the medical sector. When do you start with medical? And that has nothing to do with rail anymore, as you can imagine. So we thought, okay, let's give it a try. So our members are always obliged to start new things. And yeah, that is now a very successful column with more than 6 working groups and trying also to overcome hurdles in medical and healthcare additive manufacturing.
Can you tell me more about some of the hurdles for each of those groups or each of those sectors that you mentioned?
Yeah, so if you start with additive manufacturing, first of all, it's always a challenge because it's a change management project. It's not a technology one in the first hand because you have to change the processes in companies, the same, by the way, in hospitals. So if you want to integrate additive manufacturing or 3D printing in your company, you have to be aware of your different processes. You need well-educated staff. You need the machines, of course, and also the investments. And you need to know what can be done and also what can't be done. And this is exactly where Mobility Goes Additive and Medical Goes Additive tries to help, to give a guidance for those companies, what can be done, and to find their path through different technologies and materials which are already available at the market. And yeah, there are still some hurdles. One big hurdle is still costs. So additive manufacturing usually still is a very good technology if you need small numbers of pieces. If you have mass production, it also depends on the use case, but we would tend to recommend former technologies. But if you have small numbers, if you have very specific designs, if you want to do a customer-oriented product, a customized product, then additive manufacturing is a perfect solution. This is, by the way, also the reason why additive manufacturing plays such a big role in medical, because then you can produce customized patient-specific implants and tissues and whatever is needed. And that can also be used, of course, in other products. So as I've mentioned, I come from the rail sector, and we started with printing spare parts we can't get anymore at the markets. So we call it obsolescence management when we need very small numbers of parts. And yeah, it's really hard to find a supplier. Sometimes they don't even exist anymore. Or if you have very long lead times because there are just small numbers which are needed, then additive manufacturing comes into the game. And then it's a very good solution.
You talked about this. Could you expand a little bit about the types of materials that you use currently and what you see for the future?
We have a very, very, very broad variety of materials. Just to give you an idea, in additive manufacturing, we have now more than 50 different technologies. And all those technologies cover also different materials, use cases, and sometimes even niches in different sectors and industries. So what you can print, everyone has seen that meanwhile, are those little plastic printers, which use a material formed like a cable. We call it filament, and that is heated by a hot printing head. And so it becomes a bit liquid, and then layer by layer, it's brought into shape. Therefore, of course, you would need a software, because before you need to have a CAD design of your part. But that can be done now quite easily. And then you can print it in different materials. And those materials can be not only polymers or plastics. We have many, many different alloys of metal, and very easy to print ones up to very complicated ones, especially for the aerospace and aviation sector. Those colleagues, for instance, use additive manufacturing to produce parts much lighter. So lightweight designs play a very big role in aviation, because every kilogram you don't have to bring into the air saves a lot of money. Someone even said it's like $10,000 over the lifetime of a plane, which can be saved with a printed part. So 1 kilogram, which you can save, means $10,000 in savings. And that is due to the different kind of production. So you don't have a big part where you try to machine something out of it. You can print just that part what is needed, which means that you can also save a lot of material in the production already. This is also why additive manufacturing is a very sustainable production method. You do not need that much material anymore. And there are so many technologies now out there. You can use also resins. Resins means that you have like a little bath tube full of liquid material where with lasers you print layer by layer. And this layer by layer structure means that you produce differently. So you have to slice your part you want to produce. You can also print powders, and those powders can be polymer or plastics, that can also be metals. You can also print with metal wires. It's a bit comparable to this formerly mentioned technology where you use plastic cables. You can also use, of course, in different machines. You can also use metal wires, which are melted using either lasers or electron beams. And now you can already see there are so many different technologies out there, even up to printing with concrete. Whole houses up to 3 stories have been printed already. And the big advantage is that you do not use that much human resources anymore. And that is really a lack in that industry. So you can print whole houses now using additive manufacturing. One of the trends is also using it in medical devices, and also using tissue. Yeah, so you can print tissues. So for instance, there are some university hospitals, it's still in an R&D, but you can print, for instance, skin. So for burnt people, that might be a solution. It will take some more years, but that is already in the pipeline. And there are even some companies, mainly coming from Israel as well as from Austria, and they are busy with printing food. Yeah, it's a bit like tissue printing. So you can print either materials which are very similar afterwards to maybe meat structures. And with this different kind of technology and this layer by layer logic, the taste is different. Yeah, so the haptics are different. And this is how you can print meat-like materials. It's not meat, of course, but in the mouth, it feels like meat. And therefore, different materials are used coming from soy as well as beans and peas. And yeah, that also helps to save emissions. Yeah, that's the trigger of those guys who invented those technologies because they don't want to have that many cattle being raised. And one of the latest trends is even not to print something similar to meat, but to print meat. You can use stem cells to reproduce those cells and then print it into a structure so that afterwards you have like a steak, but no animal died for that. And that also helps vegetarians and vegans, but also other people because sometimes they want to have the taste of meat, but they don't want to have an animal dying for that or with the big emissions going along. At the moment, that is not in the mass production due to ethical discussions, because it's not solved yet, the discussion around what are we allowed to do with stem cells in general. Because, of course, you can not only print meat or things like that, you could also do other things. And this is something which has to be regulated before, but to give you a glimpse into the future, that's the logic of a replicator and the future-oriented sci-fi films and movies, and that will in one day will come. It's really, really, really inspiring and amazing what we can do.
Can you tell us more about the process and structure of printing foods?
Yeah, so the process is always a bit similar. It's this layer by layer. So you have a product, and that can also be a spare part afterwards, yeah, made from different materials, of course, and in different machines. But before you have to design a part. If you've designed that part, you have to slice it into different layers. And then you start producing it with different technologies. And with this different kind of technology, you can also put like little holes into your part. You can do totally different structures. You can do cooling channels. Yeah? And similar, you can also do this with meat-like things. And therefore, the haptic, the taste, and things like that are different from other produced parts. And this can also be used, of course, that was something very extraordinary to talk about printed food. But if it comes to more traditional use cases like spare parts or parts for different sectors, then it's also a great logic because you can design things differently. You do not use the formally known design rules anymore. And that makes it really interesting because you can combine parts. We call it functional integration. So you can produce parts which you don't have to assemble afterwards. Yeah, so you can save a lot of working steps and make maintenance much easier afterwards and produce in a totally different manner. And this is, by the way, what is also used, for instance, in aerospace. Yeah, if you have very complex aerospace parts, as well as you need very complex cooling channels for different technologies. This example for that would be the oil and gas industry. Then you can do very complex designs which were not possible before. And therefore, you can save a lot of energy. You can save a lot of heat and whatever needs to be invested over the lifetime of such a used part. And that makes it really, really interesting to many, many sectors. In rail, we started with very complex spare parts, for instance, yeah, but you can also do tools, yeah, if you want to have parts printed which make your production easier. That's also a very interesting point. So, for instance, printing jigs and fixtures to help you to assemble machines, or in our case, locomotives and trains, then you can save a lot of manpower. And sometimes, to give you a very simple example, we had like little jigs which we wanted to use for putting stickers on seats. So if you look in your front seat, you sometimes see like little stickers with different information. And before, someone had to measure exactly the seat. And meanwhile, we have this very simply printed fixture for the sticker, and you save 2 to 3 minutes per seat for putting the sticker on the seat. And if you have in mind that there might be trains with more than 1,000 seats, then you know exactly what this means in terms of money and savings. And that, of course, is the very easy, low-hanging fruit harvesting logic, which you can also get with additive manufacturing.
Are there additional safety or quality requirements for other industries?
Oh, yeah, definitely. So those safety regulations, of course, always play a very big role. I've mentioned already a couple of industries like oil and gas, aviation, aerospace, automotive, as well as rail. And there are some more, and they are very much regulated, which is good because that saves lives. And of course, if you want to replace parts with additive manufacturing, you have to be aware of those certifications and regulations. And then you have to fulfill the same quality levels with additive manufacturing. And of course, you have to prove that additive manufacturing can do the same. So with machine parts, that's totally fine. We know exactly that quality levels are at least similar in AM, sometimes even better. But therefore, you need the certificates. And this is why I've mentioned that additive manufacturing is also a change management program, because before you need to convince those people in your company or in authorities that additive manufacturing is a reliable technology. And that still is a big task. And this is why it really makes sense to come together in networks like ours, because then, of course, it's easier to prove that. And we have approval working groups in mobility as well as medical, because the detailed regulations are different, of course. But the overall logic, how to convince such authorities, is usually the same. And that takes a lot of time. This is also one of the hurdles which still exist. And we still need many more norms. So it becomes easier for the companies adopting the technology.
You have extensive experience in this industry. What are some of the most unique examples of things that have been created through additive manufacturing?
You can print very small parts, for instance, for electronics or in nano dimensions, up to very, very big parts. So the variety is so big. You can print for so many different industries. When I started with additive manufacturing, I was really blown away by another example. I always wanted to have individualized shoes. Yeah, that's a very personal subject. And what you can, of course, do is you can print your soles and also insoles with additive manufacturing and produce individualized shoes. I think this is the dream of at least all the women, and I'm quite sure that most men would say the same. So I really like those stories, what you can do, and democratize also a bit. You do not have to spend this awful amounts of money anymore for individualized items. If you look at different industries where additive manufacturing already plays a very big role, that is also, for instance, dental. If you ask people in a room who already wears printed teeth, you will always find at least 10%. So printing dental applications is very, very common. And you might also know these aligners, those translucent things to correct teeth. They are all produced using additive manufacturing. Yeah, so you scan your teeth, then the model of your teeth is printed, and then you produce those invisible aligners with that. So that is also quite interesting. What I really like is also printing implants. And you can do this individualized already. I already mentioned tissue engineering, tissue printing. So organs will be printable. Not yet. It will take another, I would say, 10 years at least. And that's on the way. But if you really want to save a lot of money, and I come from economics, I'm not an engineer, I think it's also quite interesting that you can print parts which you usually store in a physical warehouse. And this is amazing what kind of huge savings might be realized with additive manufacturing. So just to give you an example, Deutsche Bahn, the railway company, has spare parts just for the rolling stock, not talking about infrastructure, worth $1.8 billion a year. And already today, we know that we could print 10% of that. And that's pure cash out. Yeah. And this is just one example. You can take whatever industry with long life assets, yeah, where you can do the same. And just imagine what you could do with the money and also by the way, with the material and emissions, which are not stored in physical warehouses anymore. So that will definitely change the art of storage, the art of production, the art of manufacturing in the upcoming years and decades.
What role does AI play in additive manufacturing?
I mean, there's nothing where AI does not play any role. Yeah, so it's really interesting. There are very simple things because in future you can address your ideas, talk it into your phone, and I want to have a little figurine which looks like me, upload a picture, and that should be like a monster in different colors. And then the design will be produced using additive manufacturing, then it will be sliced, and then you can print it. And of course, AI is already used also in industrial production. So you can also use it already for the design of parts. So that will make the design by far easier. At the moment, you would still need very well-trained people up to engineers. Then you can also use it for quality measures. So you measure your design before and you put it into your AI, and afterwards the printed part is compared by AI with the formally designed. Then you can see immediately what are the differences. In the build process, you can use AI just to identify immediately where might be a potential weak structure in the printed part. So there are many, many different kinds to use AI, also in the identification of potentially printed parts. So if you have a huge physical warehouse, for instance, you can also use AI to analyze which kind of parts are printable already and where does it make sense. And these are just a few mentioned potentially usable AI applications, and there will be by far more in the future.
What design opportunities do you see for engineers, specifically within additive manufacturing?
Yeah, so design opportunities, of course, it makes a lot of sense when someone who designs a part with additive manufacturing that we have a specific training for them. We call it design for additive. I already mentioned the challenge that we can also integrate different functions into the same part. And then you need the creativity to think differently about parts, to integrate those, to make them lighter, to make them differently from today's structures and designs and geometries. And that is a big task, of course, for engineers. But from my experience, this is exactly what brilliant engineers are looking for. They need a tool to materialize their ideas, and that is additive manufacturing. And if you train them, if you give them some seminars, they can still learn it also on the job. There are many, many more universities now out there where it's also part of the curriculum. But even if those people have already finished their studies, they can still learn it. And we already talked about AI. That will be also a very helpful tool in the future to make also those designs much easier. And what we can see already now, there are architects out there using additively produced concrete to do different shapes. So you don't have a very strictly right angle design anymore, but you can do rounds and different shapes of walls. And you don't have those restrictions anymore.
If you are interested in more content on additive manufacturing, be sure to visit Mouser's Empowering Innovation Together page to explore a variety of articles, videos, and more. Stay tuned as we delve into the newest technologies, including our upcoming feature on urban air mobility. Visit mouser.com/empowering-innovation.